Hello, everybody. Welcome back to the Science, Facts, and Fallacies podcast. This is episode 314. My name is Cameron English. Excited to be with you as always. We have a very special guest host, former heavy metal bassist Kevin Folta is here.
Wow.
That's his true expertise, is doing gnarly breakdowns in heavy metal bands. I'm kidding, of course. Kevin is the founding co-host of this podcast before Dr. Liza Dunn stepped in. He's also a plant geneticist at the University of Florida and a lifelong farmer.
Yeah, but you know the siren song of 4 strings of catgut. I long for this. Yeah, no, it definitely was a good time playing a lot in high school and in college, and we actually did played a lot of places and toured a lot in the greatest band that nobody ever saw.
My first introduction to your musical abilities was your episode on Joe Rogan when he actually brought up some of the old songs you guys played.
Well,
That was
yeah,
so awesome.
it was funny. We kind of stumbled into it because he was saying, "Oh yeah, well these science corporate guys." I said, "No, I'm a university professor. I used to play punk rock with a band." He said, "No way, you didn't play?" I said, "Yeah, And I said the name of it, and it got lots of hits online when people looked up "Insane War Tomatoes," which we have a great documentary online. It's all been there since the '80s, and the music holds up really well. Holds up much better than things like Prince. It really does. It sounds good. It doesn't sound like the '80s. It sounds like
It sounds like badass punk music. It's not like Air Supply or something. It's
yeah. Well, our problem was that we were at the cusp of punk rock and metal, and so all the metal guys hated us because we were too punk rock, and all the punk rock guys hated us because we were too metal. So the only people who showed up were some people, like a handful, and we'd do this gigantic stage show that would take us a day to set up and a day to tear down, and we'd play to 18 people in Green Bay, Wisconsin, but it was awesome. It was a lot of fun.
Yeah, man. The formative experiences. Everybody needs some outlet like that, whether it's music or anything else. But
Yeah.
and all that to say, I'm glad to see you again. It's great to chat. You do important work, and I always value your expert insights. And they're going to be helpful here because we're talking about a story that was written by Dr. Andrea Love. She runs a Substack called Immunologic, and she's an immunologist, and she has other expertise, but it escapes me right now. But she's a great science writer, a great communicator, and the article's called Food Dyes, Herbicides, Vaccines, Water. I never know how to say questions. Yes, they are all toxic depending upon the circumstances, so beware of scare claims. Great stuff. What I love about her is she breaks down fundamental science concepts. A lot of stuff you read online, it's factually correct, but it will start with the premise that you're stupid and vaccines are awesome, and then it will explain a little bit of science, and then it ends with, and by the way, you're stupid and vaccines are awesome. What she does here that I appreciate is she breaks down concepts like dose, and she explains what toxic actually means. And this is the sort of stuff, if people are willing to read it and challenge themselves, they'll walk away with more information that will inform them, and that's what I really appreciated. So maybe we could start there, Kevin. I know that's more about sort of an abstract communications point, but I know that's your passion. So what did you think of that?
Well, I agree with you on your point, and I think everybody should follow Andrea if you can. Dr. Love is a wellspring of information, and I really do appreciate it. She's a friend, she's a colleague, she's somebody we write together very well. I really appreciate writing with her because she's very my stuff comes back better than it went to her. And long story short, but the other thing about her is she's amazingly prolific. And when you look at the amount of material she produces day in and day out, and the quality of that, it's like I can't come close to doing the quality of this stuff. And as you mentioned, she takes topics and makes them not only understandable and attractive to the average listener, but even a seasoned veteran like me can take an article like this one and find something really cool that makes me a little better in engaging with the public. And I think this is just such an important topic because she talks about toxicity. What is toxicity and what are some of the nuances of toxicity? And the reason that's important is because quantitative analytical chemistry has gotten really good. And we can measure chemistry to the point where it's almost not there. And this is something I've wrestled with for the last decade, because in discussions of things like glyphosate or the dirty dozen, we can find residues if we look for them. But the residues are there in parts per billion, in parts per trillion, so it's seconds in 31.7 years, barely there. Yet we can detect it. And for the average person in inferring risk, they just know the number isn't zero. They know it's 18 parts per billion. And 18 parts per billion is too much for my kid's hot dog. They want zero. So all of these concepts like that she discusses are more important than ever, because we're constantly being told that we're being bombarded by chemistry. So when she talks about the areas that we need to think about when we discuss this, she talks about many of the small nuances. First, the dose. How much are you actually being exposed to? Obviously. And the old phrase, the dose makes the poison. How are you exposed? And is this something that's being inhaled? Is it something that's being ingested through the skin, through the eyes? There's different routes of exposure that matter. And we'll talk a little bit about that as we go along here. But what is the exact chemical that you're ingesting? And especially in the things like the PFAS discussion, there's many different species or types of chemicals that fall under a given banner, which have individual toxicity. You can't just cast an entire group of chemicals as being the same. And the other thing that's important when we look at the literature is, how was toxicity assessed in what model system? And were you looking at a rodent study, or were you looking at toxicity to cells in a dish? And that's another really important too when we look at the literature around toxicity. And these days, as people surf headlines or journal articles and don't read past, if they read past the title, they don't get past the abstract. And all of these become immediately extremely relevant in assessing our risk in response to something that's claimed to be toxic.
It's especially helpful because it's easy to manipulate scientific notation and provide numbers without context. So I see this a lot. She mentions formaldehyde in the article, and I will see examples of environmental groups. They'll take a measurement that's actually infinitesimal. It's tiny, right? Like, as you said, you can detect it, but it might as well not be there. But they'll take the number and they'll convert it into a measurement that looks really big with lots of zeros. And they'll go, there's this much for formaldehyde in your baby's blanket, right? And if you're not a scientist or you don't understand how to break down those numbers, they're like, parts per million. Million's a big number. Good gee whiz, right? I got to throw out all my kids' blankets. And I think that's enormously important. And one of the examples she uses to illustrate how this works is snake venom, right? So if a snake bites you on the arm or in the stomach or something, that could be very serious, depending on the snake, depending on how much venom they inject, which they choose to do, interestingly. Maybe choose is the wrong word, but it's not like they're going to bite you and there's going to be venom in your system necessarily. But she points out that if you actually drink the equivalent amount of a snake bite, the stomach acids in your body will actually break down the venom into harmless proteins that can't do anything, or amino acids, excuse me. Whereas if you get bit, that could be fatal. And so that goes to the route of exposure, So people, they'll see a news story about, there's glyphosate just floating around in the air and you're kind of swimming in it. When in reality, it's very low for one thing. But that exposure is different than like swallowing a gallon of dicamba or something. Don't do that. No one do that, okay? Just saying the route of exposure matters as much as the dose, which is also still important.
Yeah, that's exactly right. Kind of the snake venom example was a great one. It's the route of exposure that dictates the toxicity. And the same thing applies to botulinum toxin, which is the opposite, where if you have an oral ingestion of botulinum toxin, this kind of thing can be extremely dangerous, or like we talk about botulism that comes in through spoiled food, things like that. But this extremely toxic compound, one of the most toxic compounds on the planet, people go pay thousands of dollars to have it injected into their faces. and this one always amazes me, because I would love to know How many of the folks out there who are vehemently against things like glyphosate or genetic engineering or the things that pose a very little risk based on dose are actually doing the botulinum toxin? Because I bet it's a lot of them. And I've seen them. and you know, they have very forced smiles and facial expressions, probably because they're numbed up from botulinum toxin. She also talks about water, which is a very interesting one, because we talk about water, and I always like to use this example too. Water can be extremely toxic, and if you drink enough water, you can go into, especially more distilled water, you can go into a state called hyponatremia, where you essentially remove or drain out your electrolytes. And you actually get a little bit of a buzz and that kind of thing from it before, and it can be fatal. And I mean, I remember when I quit drinking, I would go to the bar and just order water and give me another one, because you could get the buzz from water if you drink too much of it. Not really, but there is like a euphoria that comes from drinking too much water. Kids, don't try this at home. But I guess the other thought is route of exposure, right? That the whole dihydrogen monoxide inhalation problem, where if you actually inhale water, it can be fatal, right? So it all boils down to the different type of compound that you're talking about, the different chemistry, the route of exposure, and how much you're exposed to. And I think when we give these examples, I think, and it's good for anyone who's interested in science, who engages the public, have botulinum toxin queued up and have rattlesnake venom and water queued up, and be able to explain how these three things vary in toxicity and their depending upon route of exposure.
A little while back, I was watching a webinar by one of these NGOs because I'm a masochist, and the presentation started. They were talking about some industrial chemical and why it needs to be banned, and you know, your kids are going to be born naked and illiterate if they're exposed to it. And she started her presentation. She went. Okay, everyone, break out your glass of wine because this is going to be a tough conversation about a carcinogenic chemical. And I almost, like, she could have heard the guffaw through my muted mic, because, as everyone should know, regular alcohol consumption in high enough quantities can really increase your risk for certain cancers. And yet here she is like, well, everyone get a little buzz because we're talking about this chemical that, 50 years ago you might have been exposed to in a quantity that could have potentially been harmful if you worked in an industrial setting. It's just like the absurdity of it. And in her defense, I think she probably just didn't know. I think she had been tapped as sort of the face for the campaign that they are running. But the people who employ her know much better. These are high-powered environmental attorneys. There may be a toxicologist in the mix somewhere at EWG. I'm honestly not sure. But the point is, this is deliberate in many cases, right? They're presenting information without context to mislead people. And that's what I think drives me nuts, and you and Andre and everybody.
Yeah, that's a great example, because I remember seeing pictures of the food babe drinking a big glass of wine or posing with a big glass of wine and telling me about the toxic chemicals in my food. And, she goes after different things like glyphosate, which if it's there at, 50 parts per billion is a problem, because or different groups will say 50 parts per billion is actually detected in wine. So 50 seconds and 31.7 years. Yet, and so glyphosate is a controversial class 2A probable carcinogen by the IARC, and even that's highly debatable. And 10 years after that determination was made, we haven't seen any evidence showing that it is a carcinogen. But anyway, 50 parts per billion of a potential maybe far out carcinogen, or the 130 million parts per billion of a class 1 carcinogen, ethanol, which is in that wine. So it just is another opportunity for us to take our eye off the ball. And I also think that when we start talking about things like food dyes, like they'll say, make America healthy again, let's take out food dyes. And if you're not starting with alcohol and ethanol as a public health threat, then you're not really looking to make America healthy again. When you look at, and I'm not like an anti-alcohol person. I'm very pro-alcohol. I like a beer and a gin and tonic as much as anybody. But really, when you look at health ramifications of excessive chronic consumption, that does have a very certain impact, not only in cancers, as you mentioned, but also a series of other health impacts. And so if the Make America Healthy Again movement was being honest and really being scientific, sorry, I just realized how dumb that sounded. If they were really being scientific, they would be not focusing on food dyes, which are not a problem, and misinterpreting the food dye literature, and maybe starting with the elephant in the room, which is ethanol, which we know has a problem in health.
Well, see, that could irritate some people's Friday nights, Kevin, and I don't think anybody wants to do that. On the food dye thing, it's really funny. I'm drinking Gatorade right now, and it's called like Frost Glacier. It has some dopey, like river freeze. It gives it this cool, sexy, kind of rugged flavor, and they make it look like frosted ice, but it's done with food coloring. And I got to say, there's no risk in that whatsoever. But if it was the color of poop brown, I probably would be less inclined to drink it, right? It's not because it's any worse or the flavor's any different, but it's like the color makes things appealing. And I think that's okay. This is one thing we overlook sometimes. Not everybody, but some people tend to overlook. We get so hung up on these technical, mechanistic details where it's like, well, it's okay that a company wants to market a product to you, right? They want to make their strawberries, like as your recent article said, right? They want them to be sweet. They want them to be that bright ruby red. They want them to be the size of a fist. And I love that when I look at a strawberry. And that's okay, right? So the fact that there's a company that makes their orange soda look orange, not a big deal, right? Don't drink too much of it because there's lots of sugar in it, but that's okay, I think. What do you think?
Oh, same thing. I mean, it's taking our eye off the ball of what the real health problems are. And when you look at, like you mentioned, sugar, which we consume way too much of, and I'm watching my kids, grow up now, and my daughter, which is really interesting, that when she started eating on her own, eating solid food, she's almost 2 now. When she started eating solid food, she was eating vegetables and fruit and loved to eat really healthy stuff, no problem. But once she got into what I'm calling yummy food, things that were kind of designed to appeal to the brain and change what our expectations are, you can see her food choices now are completely different. She now, if you give her a plate full of Cheerios, fresh fruit, and toast with some peanut butter on it, she'll go for the Cheerios first. It's all about and there's no question, because she just isn't watching documentaries. She isn't being swayed by the internet. This was a real experiment where we basically learned that the things that are manufactured to give us all of the things that we find attractive in food make us more excited about food. And I know it's an N of 1, and I know it's just my observation, but it really was interesting to see that transformation of a diet and choices in my own daughter. Just a little sponge that had no other influences other than the food itself. It was pretty cool to see that.
Yeah, well, and we discussed your article last week, by the way, and one thing I appreciated about it is you said, even if the nutrient content of a piece of fruit is slightly lower, if it tastes better, people will eat more of it. It's kind of like the Laffer curve argument, but for fruit. It's like if you make something appealing, people will eat more of it, and that's really helpful, right?
Oh yeah,
Go ahead, please.
Well, yeah, that you just I'm sorry I jumped on you there. It's that people miss that point, is that it doesn't have as much nutrition, but nutrition only counts as if you get it in your face. And if you're, and so having things that go bad, having poor post-harvest quality, having things that are unattractive to eat, certainly that is having it stay attractive and getting more of it in you is most important. Today I was harvesting peaches, and it's beautiful. Oh, isn't it awesome? It's peach season at Folta Lago, and we had You find the ones that have a little bird peck or a insect hole or something, and it's like, that one's for me. The ones I can't sell at the market, I sit out and eat peaches out in the field. Oh, it's so good. But anyway, if in order for me to sell it at farmer's market, it has to be absolutely perfect.
Yeah, it's a great point. And it's funny, everybody behaves that way, but then they tell other people that it doesn't matter, right? Like if your food looks gross, you're less inclined to eat it, and that's been studied pretty well. But you will tell other people, like, just eat the nutrient dense stuff, and just just get over yourself, right? This isn't about your flavor or it. I heard Callie Means make that point, like, we're not going to let the food industry hold the American health hostage with food prices. It's like you're such a clown, right? You're so removed from the average working person's experience to treat food prices or flavor or palatability as that's for the pros, right? Us sophisticates understand what's good for you, and I can't. Anyways, not to go on a rant. To get back to Andrea's article, she makes an awesome point. You mentioned Botox already, but she says, fun fact: the word toxin specifically means a chemical produced by a living organism that can be harmful at a certain dose. In fact, all true toxins are natural chemicals. Did I just blow your mind? Now, as I read that, I could see the cognitive dissonance in people's heads, just like, wait a minute, but natural is good. And maybe that's where we could turn next. I think one thing that might help with this natural versus synthetic thing is if we could start talking about chemicals as whether the effect is good or not. Like, that is actually natural. Like, if it comports with your biological human nature, it's good, right? So if you take a pain reliever and it reduces the inflammation and it eases your pain, that's natural. That's good for you as a human, So it's not like how the chemical is manufactured, but it's what your body does with it. Does it know how to metabolize it, and does it have the effect that we want? What are your thoughts?
Oh, same thoughts. Is everything is putatively therapeutic. If we look at medicines, for instance, there's a therapeutic range and there's a toxicity range, and there's a no effect range. So if you're looking at that curve, there's no effect until you hit a certain dose, where you see a dose response relationship that's generally very linear, and then at some point you reach a saturation where no longer dose causes any change in the effect. You take enough aspirin, you don't feel the effect of the headache after the headache is already gone, no matter how much more you take, right? So in this case, you've reached a plateau with respect to your response to the dose. But then there becomes the toxicity side of this, that if you continue to take higher doses, you reach a point where it does matter and it becomes toxic. And all of the toxicity and dose and all these things, also, as you mentioned, there's roles of pharmacological fate. How does it break down? What are the enzymes that do it? Where are they located? How is it mobilized within the body? Where are the enzymes in the body? Typically, these are enzymes in the liver that do the metabolism. But all of these other factors matter. What is the half-life of this compound in your body? How is it excreted? Is it turned over? All these other factors play a role in the pharmacology of any given compound that's introduced to human physiology. And so this is the other aspect that everybody largely ignores. They'll see the skull and crossbones on the bottle, but fail to pay attention to any of these other factors. And a funny one that's in her article, she has a table in there where she shows aspartame. And in the parlance of artificial sweeteners, people are always going after artificial sweeteners. So maybe some data on erythritol that are compelling, but in general, pretty safe. And I once got into a discussion with somebody about it, and they said, "You don't know anything about aspartame," which I thought that was really funny.
Yeah. We have our weekly spaces on X, and you've come to a couple of them, but
yeah,
they've been really informative, and it's enlightening for me because you get to see where people actually are when they come. So one lady showed up and she said, "I'm so sick of this GMO wheat. They're putting it in everything. They're poisoning everybody." And like we let her finish and go like get, like the Energizer Buddy, just get it out. Like it's okay. It's okay. We're here for you. We'll get through this. And then one of us stepped in and said, "But there is no genetically engineered wheat on the market."
Yeah.
Like that might change. Like there has been R&D into that. But, so like your whole premise is you're being poisoned with this thing that isn't technically real. So I think that's really important, that people really don't know a lot of this stuff. And it's not that you're a genius if you know it. It's just that it takes time to absorb information and really understand. And it's so easy to get overheated on stuff. And I'm very guilty of that in other domains, like politics or other stuff. It's really easy to see something online and just be like, I'm ready to go, man. But you got to step back. And I think this is the sort of material that scientists can produce that will help people with that.
Yeah, well, it's also the philosophy of science too, is that we like to look at evidence before making conclusions. And I've seen the wheat thing over and over again. That people will tell you it's Monsanto's wheat, that Monsanto is poisoning us with. There's no genetically engineered wheat sold in North America, and Monsanto hasn't been a company for 7.5 years. So isn't that weird that that's 7.5 years already? That's gone. I think that's 7.5. Well, 6.5.
They're still running the show. They're in the back room with their cigars. I know it.
That's right. They're still running it. They're still pulling the puppet strings from. Someone gave me a Monsanto ashtray. I thought that was really.
Monsanto.
It's really cool. Actually, I could probably show it because you were here on the film here.
Yes, do it. Do it. I want to see this Monsanto ashtray.
This is kick ass.
We'll have to make a clip of this Monsanto ashtray. I love it, and it's in red. It's in red like a Marlboro. That's awesome.
There's so many things that are cool about this, and that it's a Monsanto ashtray, but it's an ashtray. You don't even see those anymore.
Yeah.
Ashtrays and paperweights. Now that we have air conditioning and cancer, we don't have these things. But I thought that was really neat. That's really fun that someone gave me that. But I guess back to the point is that there is a place for us when we talk to people and engage the public to discuss how important it is to be making decisions from evidence. But like you say, everybody's got their own reality, and we've never seen that more than we see it today. And whether you're talking politics or science or toxicity, it seems like we're operating in a world where everybody has a reality that they're adhering to that isn't necessarily based in evidence. And that's been, and I think that's really a problem, especially politically and scientifically too. I mean, we see what's being unraveled at the federal level now in terms of science. That we're taking a red dye out of. We want to take dyes out of food that don't do anything, but then cutting the programs that actually are highly effective at helping public health. It really is a strange time.
Yeah, it's the thought of uttering Health and Human Services Secretary Robert F. Kennedy Jr. Like that's a fever dream I never thought would be a reality, and yet here we are. It's just such a crazy world. So we're in for a ride the next 3.5 years or so, whatever happens. Our colleague Dr. David Zarek is convinced that Kennedy is just going to get antsy and quit because he's not going to be able to move forward as seriously as he wants, because the gears of government are like molasses. They're so he's not going to. Yeah.
The gears of government are like molasses, but he's also going after molasses. Like now he's going after sugar, where there's going to be a phone call to the White House from the sugar producers that says, maybe get your guy to back off a little bit. And then when he starts going after seed oils and the soybean growers blowing that call to the White House and say, maybe a good idea for your dude to back down a touch, because scientifically he's wrong on these issues. But as you say, I never thought I would say HHS Secretary Robert F. Kennedy. I've been hating on that guy for a decade. But the good side about it, if there is one, is that it makes me feel like I've got a shot for Pope as a dark horse candidate. That if he can be HHS Secretary, I just might be Pope John Paul Ringo George.
First heavy metal bassist in the Vatican. I love it. Okay. So as we wrap up here, Andrea makes a great point that this is the sort of stuff like you can go into a conversation with, And it will force people to either stop talking or they will have to rethink a few things. So she says, if you hear someone saying some substance is toxic without context, they are misleading you, either intentionally or unintentionally. Ask them, at which dosage, in which organism? If it's an insecticide or an herbicide, does it have an impact in humans? If you just stop someone in their, like before they start throwing PubMed abstracts at you on Twitter, you go, wait, okay, what was the animal in the study and how much were they exposed to? Like right there, they're going to be like, well, that's not in the abstract, so I'd have to go read the paper, which I have not done, right?
Right.
And this is a tactic, I think, as we've talked about before. You've used this too. You go, hey, tell me about the methods section. What assay did they use? And right, that shuts it down. But the important part is everyone watching that interaction goes, hey, wait a minute, that guy just turned tail and ran from Folta. What's going on? And then they have to sort of think through what they're reading.
Yeah. No, that's exactly right. And those are such important points. And she brings up those points in here too about the, what organism is it done in? So many of these things are studies that are done in a petri dish. Mm-hmm. So they take a layer of cells and then they expose it to some chemistry and then show some change in cellular metabolism or cells die or whatever. And I've done tissue culture with mammalian cells and it sucks. That I remember doing transfections and things where, if you look at them wrong, they die. And so changing the media and everything has to be precise and the level of every gas in the air inside the chamber where they grow. All these things have to be so tightly monitored. So to find something that perturbs that is not a bridge too far. And you could do it with sugar, you could do it with Windex, you could put distilled water in there and it's going to kill them. So that's a lousy model. It's a great place to start, a great hypothesis generator, but that's it. And the other thing that she mentions is the animal studies. Animal metabolism is a little different than human animals. And so it's, again, a good starting point, but it doesn't necessarily translate directly. And that idea of how much are they being exposed to. The famous one is the paper from, what's her name now? Whetstone et al. In 2023 on glyphosate and Alzheimer's, where the popular media had it causing Alzheimer's because they could detect it passing the blood-brain barrier and it associating with markers of inflammation. And what they showed was this would happen in rats, or mice maybe, if you fed them 500 milligrams per kilogram body weight for 14 days, which if you're 100 kilograms like me, means I'd have to take something like 50 grams of glyphosate, which 250 or 50, just a ridiculous amount of glyphosate that you would have to consume for 14 days to get that outcome. Which really, if anything, says, look how safe this product is. That you could consume such massive amounts and barely find anything. So all of these are really important considerations. Andrea's article is awesome, and everyone should check that out and absolutely should follow her. It's always a good read.
Yes, indeed. As we wrap up, my favorite example of the cell culture, I guess this would be rodent and cell culture stuff, but they took tumor cells and they injected it intravenously into the rat's tail, which gave the rat cancer. I didn't know you could do that. But the rats have these proliferating tumors in them now, and they go, yep, the rat's got cancer, and then we exposed them to this chemical, and the cancer got worse. I'm like, okay, I think you skipped a step, right? Let's start with, does the chemical give the rats cancer? And then we move forward, right? But you can't, like, I chopped off its tail, and it was really mad. Like, what did you what did you prove exactly?
Right.
So something to be aware of out there. We want people to follow you. You're on X, of course. Apparently, you're on OnlyFans. How's that going? Is that a good side hustle?
It ain't working out so hot. It's I get requests occasionally from weirdos. They want my socks. I don't know why. If you could wear them and walk around in them and send them to me, I'd like okay, well, so it's not the income generator that I thought it would be. So I'm probably not going to. You can find me on the Talking Biotech podcast. I've been on a couple months hiatus just to kind of reorganize and get my. It was one of these things that I think I'm feeling a little bit of pressure. It's been 10 years for Talking Biotech podcast, and I think that when everybody's got a podcast, I feel kind of weird saying, can you listen to my podcast? Because everyone's got one now, so it's not like something cool that I did that was really innovative. You know what I mean? Like when my wife's brother says he's got a podcast now, and I go, okay, it's like everybody's in the pool, and it's not as interesting as it used to be. But I do think the upcoming episodes are pretty good. So that I am on X, not nearly as much as I used to be, but also have a professional Facebook page at KM Folta, Kevin M. Folta with middle initial M. And you can touch base there. That's always real good too.
Yeah, and then your handle on X is at Kevin Folta. Mm-hmm. And I know you said you're not too active, but you're active enough. And then you write pretty semi-regularly for Genetic Literacy Project, and your stuff's always really helpful. So check out those resources. Kevin, thank you so much for being here, stepping in the breach while Liza is traveling the world, as she frequently does. I really appreciate it. Thank you to everyone for joining us. As always, I appreciate you very much. Follow us on X. It's at Dr. Liza MD. I'm at Cam J. English. Thank you so much. We'll see you next time.